Okay, on the third section, or the third part of section 2.3, we have an absolute value equation that has two absolute values equal to each other. So you have the form absolute value of ax plus b is equal to the absolute value of cx plus d. So this looks a little bit more complicated, but actually we're going to treat it very simply. And that is, when you have two absolute values equal to each other, then you can just take away one of the absolute values and treat it the same way that we would any of the other problems that we've been working with. And so that means that you could say that absolute value of 3x minus 4 is equal to x plus 6. Now, that may be a stretch and you don't understand why that works out the way it does, but it's a very simple and straightforward way that we go about solving this. And so I would just suggest that when you have absolute values equal to each other, then it is okay to take away one of the absolute value things. And we're just going to work from there. Now what's a little bit different even when we do that is that we don't have a number on the other side. So we can't say that this number, absolute value of 3x minus 4, that 3x minus 4 is so many units away from 0 on the number line. It's now x plus 6 units away from 0 on the number line. And so we would either say it's x plus 6 units to the right of 0 on the number line, or x plus 6 units to the left of 0 on the number. Now it's important when you do the one on the left that you don't write negative x and then plus 6. It has to be negative of the quantity x plus 6. You have to put that in parentheses. And so that leads us to two different equations again. And we would get 3x minus 4 is equal to negative quantity x plus 6, or 3x minus 4 is equal to the quantity x plus 6. On the left side, we would first distribute that negative 1 to both terms inside the parentheses, and we get 3x minus 4 is equal to negative x minus 6. And so this goes back to an equation where we have x on both sides, and what I would do is pick on the little guy or get rid of the smallest x as my first step. And that smallest x would be the negative x. Remember that any negative number is always smaller than a positive number, regardless of how big the absolute value of the number in front of x is. And so I'm adding x to both sides, and I get 4x minus 4 is equal to negative 6. Then my next step would be to add 4 to both sides. And when we do that, we get 4x equals negative 2. Dividing both sides by 4, we ended up with x is equal to negative 1/2. Alright, and we'll double check that in a second. And let's solve the other equation, which is 3x minus 4 is equal to x plus 6. Again, in that one, the first step, since we have x on both sides, my strategy is pick on the little guy, which is to get rid of the smallest x value on either side, and that happens to be x. And I'm going to subtract x from both sides now. And that gives me 2x minus 4 is equal to 6. When I add 4 to both sides, I end up with 2x is equal to 10. Divide both sides by 2, and I get x is equal to 5. Right, so those are my two values of x that should make this a true statement. So this time I'm going to go back to that original equation, because I really have to show that these two values of x make that original statement a true statement. So I set up the equation, absolute value of 3x minus 4 is equal to absolute value of x plus 6, and I'm substituting x equals negative 1/2. And when I do that and multiply 3 times negative 1/2, I get negative 3/2, or the absolute value of negative 3/2 minus 4 is equal to negative 1/2 plus 6. Now, however you go about doing this, negative 3/2 minus 4 is negative 5.5, and so we have the absolute value of negative 5.5. And on the right side, 6 minus 1/2, or negative 1/2 plus 6, is also negative 5.5. Sorry, that's positive 5.5, and they have the same absolute value.